Hello everyone, this is KP the Math G here, and we have a problem for you. I've been doing calculus problems for some time, and most of them are now free response questions, and I love this one. It's coming from the 2021 free response question number 5, and I'm going to do a couple of these. I cannot remember for the life of me which part that is. So let me look. That is part C. Okay, that's what we're going to do. We're going to do part C, and later in another video we're going to do part D. This video is going to make the 149th video, and then part D will make the 150th video, and then we're going to go from there. We're going to keep going. I don't know I don't know if I'm going to reach 200 or not, but we're going. That may be a goal for me. So we'll see. All right, and it keeps my mind sharp, even though I haven't been teaching now for a couple of years. But I enjoy doing this. This is a neat problem. I want you to know that. It says, consider the function, this is 2y squared minus 6 equals y times sine x for y greater than 0, so y is positive. It is given from part A that you had to show that dy over dx is y cosine x over 4y minus sine x. That's easy to be done. You can do that by the quotient rule. That would be one way to do that. Alright, so in this particular one, this is part C. Alright, so we are going, it says 4x being between 0 and pi. On that closed interval from 0 to pi, where y is greater than 0, find the coordinates. So we are looking for xy coordinates. That's what we're doing. Find the coordinates of the point where the tangent line to the curve is horizontal. Now, horizontal. That's a horizontal line that's going, let's say if this is x and y, your horizontal line would be one like that. Alright, so it's going to be this horizontal line. So that means that the slope of this horizontal line is equal to 0. Well, this represents the slope of this equation here. Alright, so this is the slope. So that's what we want to do. We want to set that slope equal to 0. And I had my work written down like I really need it. And that's actually from another problem. Hold on just a second. Yeah, this is, well, okay, well, if I don't have it with me, then I can certainly solve without it. It doesn't matter to me. I've done it 2 or 3 times, so now let me see. Let me just check one more time here, and then I'll see. If not, it's all right. Well, here it is. I do believe, yes. All right, so here's what the deal is. Since this line is horizontal, the slope of this line tangent to the curve is going to be, this slope is going to be 0. So this is the slope. So what we're going to do here is we're going to say, all right, well then, y cosine x over 4y minus sine x is equal to 0. What we want in this numerator and denominator, we do want, let's put this over here, y cosine x is equal to 0. we are assuming then that y minus sine x is not equal to 0, because if it did, this would be totally meaningless. We cannot have 0 in the denominator. So we're just going to focus on the numerator. Well, in this case, a times b equals 0, so that means y is equal to 0, or cosine of x is equal to 0. Alright, so since y is greater than 0, y cannot be equal to 0 because y is greater than 0. Alright, so we cannot fool with this part right here. So we got to figure out where cosine x is equal to 0. Let me move over just a little bit and draw a quick picture of cosine. Now remember, here's 0, pi over 2 pi, and really that's all we need to do is just concern ourselves with this here. I'm going to keep going though, 3 pi over 2, and I'm going to do this for a purpose, and of course you can go all the way out to 2 pi. But the cosine, here's 1, here's negative 1. It starts here and the graph comes down. Alright, so there's a 0 right there. So we know that x is equal to pi over 2, or now if we keep going, we go down to negative 1. Actually, we should stop here because the domain is from 0 to pi. But to just to show a point, if you decide to say x is equal to 3 pi over 2, well, 3 pi over 2, you need to explain, is not in the domain of this here. X is is then only in the domain from 0, including 0 to pi. So really we can stop right here. We do not need this point right here, so the only point is 0. This one right here is not part of it. You might want to explain that 3 pi over 2 is not in the domain of this, okay? Alright, so x equals pi over 2. So we have the x value. That's what we're looking for. We're looking for coordinates. So the x value is pi over 2. Now what's left to do is find the y value, and then we've got it. Now remember, when you do find the x value, where are you to plug this in? Because if you plug this in right here, well, you're going to get 0 and over something anyway, but it's not going to work here. We cannot do that. What we're trying to do is we're trying to find the y value. Don't plug it back into the slope. Okay, don't plug it into this dy over dx. Plug it back into this original equation. So we're going to flip this over. 2y squared minus 6 is equal to y times sine x. So here we go. 2y squared minus 6 is equal to let me see if I can see where I got this. Bear with me. Y sine x, yeah. Y sine x, and remember y is greater than 0. Okay. We've already found that x does equal to pi over 2. Okay, now plug that into this x right here, and we'll have a trinomial to solve. Okay, look how neat this is going to be. 2y minus 6 is equal to y times sine of pi over 2. Let's figure out what sine of pi over 2 is. I'll say y over pi over 2. Here's 1, here's negative 1, here is pi over 2 right here. Remember, sine starts here, it goes up to 1. So the y value is 1 at that point right here. Now this is y is equal to sine x. Alright, so sine pi over 2 is 1, and you can probably commit that to memory as well. Alright, so that would do you good to do that. Now y times 1, which is just y. Well, we can leave the 1 up there. So now that's squared there, by the way. So 2y squared minus 6 is equal to y. Now I'm just going to bring this positive y over here, which is going to make it a negative y, and sandwich it in there. 2y squared minus 1y, or just minus y, minus 6 is equal to 0. We know how to set that up. We should know at this level to set that up that way. Alright, so now we are, you see why I find this so cool? I really like this problem. Now we got 2y times y, 2y times y, and then I need a plus or minus because this is negative on the end. I'm thinking I want to put my minus sign here and my plus sign here. 3 times 2, put the 2 here, never match the 2 with the other 2 right here, don't do that. So 2 times 3. And remember, if we do this, multiply this out, the outer is going to be a negative 4y, and then the inner is going to be plus 3y, and that's going to be a negative 1y, or just negative y. So everything fits. Alright, so now, 2y plus 3 equals 0, or y minus 2 equals 0. Over here, if we solve here like this, subtracting 3, we're down to 2y equals negative 3, and then we divide by 2, and then y is equal to negative 3 halves, but y is greater than 0. So we cannot use this. Alright. Can't use that. Okay, so now y plus 2 on both sides. So y is equal to 2, and that is our y value. We have it now. We have the y value. So the y value is 2. And it says find the coordinates. You have to remember that the tangent line to the curve is horizontal. That means that this slope, you have to think about it then in this term, that's the key right here. The tangent line to the curve is horizontal, which means the slope is equal to 0, which means really we're just setting this numerator equal to 0 here. Incidentally, if you were to plug pi over 2 in here, this would not be 0 because sine of pi over 2 is 1, 4y minus 1 is 0, y is equal to 1/4, so we know that that denominator is not equal to 0. That's another thing you might want to check, doing this mentally here. But anyway, you have to, it does kind of, as we might say, behoove you to know the graph of cosine. There you go right there, and understand domain here. You cannot say, well, what about 3 pi over 2? Well, because we have a restriction here, x is between 0 and pi. 3 pi over 2 goes beyond that, and that was 3 pi over 2 right here. Okay, so that is not good here. We can only use what's in this domain here, and that's pi over 2. So x is pi over 2, and then plug that back into the original here and realize you have a quadratic to solve. And when we did that, we found that y is, oh, that's nice. Somebody figured that out, didn't they? Sine pi over 2 is 1. solve, and then come up with your y value there. Beautiful problem. I really like this. It's kind of like in chess, you have some really nice checkmates. Beautiful checkmates. Oh my, look at that. And then by the same token right here, this is a beautiful problem. I like it very much. So in the next video, I'm going to do question number 5, part D. It's lengthy. You do have to take the derivative of this here to be able to find. We're looking at concavity in that particular problem. So this is really nice. I love it. I love doing this. This kind of work here, it really turns me on. I mean, so anyway, not to say that this is not everything that just turns me on. The math part of this does, but now I do have my wife, and I do have, so anyway, she really makes my life good. Not as much this, okay? My wife is number 1, calculus is number 2. Alright, so anyway, love her very much, and even my dog. Anyway, very nice. Oh, by the way, before I stop, this is a picture of my first grandson, and since then, the time that I was gone, I've had a grandson from my daughter's side of the family, on my daughter's end of it, and his name is Luke. And then we had later on, just a month later, my son had a second child here. So this boy here has a sister now named Ripley, and that's kind of the reason we've been out for so long. And of course, in between all that, my blessed mother and my mother passed. I'm going to show you a picture. I know that the video is long over, but here's when I was younger. I don't know, it's an old picture. A picture of myself, and Mom, hope you can see that picture. I don't know. There it is right there. Picture of me and my mom, both of us proud of each other. And yeah, she passed in November. So anyway, have no more mother or father now, but I was blessed to have had both of them. So really good stuff here. Okay, enough of that. Just pay attention to what you have to do here, and you'll be all right. Think about what the question is asking, and then think about what this means here, and you should be okay. This is KP the Math G, about to sign off. Please, if you would like to subscribe, please subscribe. If you'd like to hit that like button, and I always smile when I talk about that. Just hit that like button. If you'd like to make a comment, please make a comment. And then I will be doing some more of these videos on a more regular basis now. Alright, that's it for today. KP the Math G signing off. Ladies and gentlemen, have a great day.